Okay. We're supposed to start with the important part, then we discuss the grade assignment. Yes, I think my screen is visible to all. Yes, I just want to confirm that what is the doubt in encoder part? Can you please tell me brief about that? What is your doubt? Or either I should explain the complete. Someone said that okay, so I just briefly describe about the encoder part. Anyone tell what is the meaning of the encoder? Yes, anyone? So basically, encoder is a converter to convert decimal number, decimal or hexadecimal number into their binary. Okay, okay, so if we are talking about the device, so we first say this is my encoder. So in the multiplexers or the encoder, in the case of multiplexer, the multiplex size is 2 raised to power n colon 1. Okay, and for this one, the 2 base of we can say the mm, n is the select line or control line. Okay, this is case the multiplexers. Now, if you are talking about the encoder, encoder is nothing but 2 raised to power n colon n. So if we have a 4 inputs line, okay, so we have a 2 output, 2 output. Okay. Now, if I say the 4 input line is I3, I2, I1, and I0, and output line is Y1 and Y0. To control this one, there is one enable pin. If we draw the truth table, enable I3, I2, I1, I0, and Y1, Y2. So when the enable is 0, we apply any of the input, the output is no output. Okay, any apply any input, the output is don't. Okay, when the enable is 1, so according to this one, we apply the I naught. So the combination of Y1 and Y0 becomes 0. Okay. If we apply a 0, 0, 1, 0, I1, the output is 0. If we apply a input as a I2, the output is 1, 0. And if we apply the input and I3, the output is 1. So basically, it converts the number into their respective binary number. Okay, if we are using the 8, okay, so if we require a 8, so 3 select line, 3 output line, and 1, 2, 3, 4, 5, 6, 7, 8. Input 7 to input 0, output 2, output 1, and output 0. Okay, now I7, I6, I5, I4, I3, I2, I1, and I0, Y2, Y1, Y0. So if any of the input is 1 with respect to this one, the binary representation of that number will be shown in the output. If Y1 is 1, that becomes 0, 0. Rest are 0, and rest are 0. If we apply at a input at Y3, I'm not taking all the case, the output is 0. If I apply the input at I6, the output is 1, 1, 0. Okay, and so on. Up to the 7 it will be going. Clear? Yes, now it's clear. In all the cases, remember that in all the cases we consider that enable will be. Okay. Now, if I want to design a 8 cross 3 encoder using 4 cross 2 encoder. Okay, using 4 cross 2 encoder. So we have one 4 cross 2 encoder, one more 4 cross 2 encoder, okay. So now you can see the 4 and 4. Total output is 8. So if I mention it I7 to I4, I6, I5, I4, then I3 to who is out. Okay. Now if we use one more close, 4 close 2, so 4 inputs are there, 1, 2, 3, 4, and 1, 2 outputs. Uh, Now please check that is I7, I6, I5, I4, I3, I2, I1, and I3. Okay? And with respect to the Y3, Y2, sorry, Y2, Y1, and Y3. Okay? Now please check. If I select, if I give a output to input to the I7, what will be happen? Just any idea what will be happen? In the case of I7, when I7 is 1, we can say these two are 1. Okay, these two are. So I just consider these two are. Any doubt in this?
So why did you take I7 as one?
Yeah,
Why did you take that I7 as one? And yeah,
I just consider the Y7 is 1.
okay.
Okay. So actually this one is the LSB and this one is the MSB. I4 to I7. Okay. So when I4 is 1, we are getting a 2 as a 0, 0. Okay. When I5 is 1, we are getting as a 0, 1. If I6 is 1, 1, 0. And if I7 is 1, 1 more. Okay. So when I7 is 1, we are using that these two are 1. Okay.
Yes.
Sir, please explain again.
Okay. We are taking this one is the I0 to I3 and then I4 to I7.
Yes, sir.
Okay. Now, if I4 is the LSB part and I7 is the MSB part, so according to this one, 4 cross 2 marks is that if LSB is G1, like for example, I take this one is the LSB I0 and this one is the I3 for this particular part. Okay. But actually, this is the I4 to I7. Actually, this is I4 to I7, but we are taking that this is the LSB, so LSB is I0 for any individual decoder. For any individual decoder, this is the I0. Now clear? Now
Yes, sir.
if this I4 is 1, that means what will be happen? We are getting output as a 0. Okay. Similarly, if I0 is 1, we are getting a output as a 0. If I5 is 1, we are getting as a 0. If 6 is 1, I6 is 1, we are getting a 1, 0. And if I7 is 1, we are getting a 1. Okay?
Yes, sir.
So when I7 is 1, we are getting a 1 1. Now what should I consider? I just consider this one is as a white window. Okay, now the remaining is I0. Now let's take one more case is that now in the case of I3 is okay, I3 is 1. So when I3 will be 1, we are getting 1 1 here. We are getting 1 1 here. So if I consider this as a y0, this as a y1, so we are getting a okay. But what about the I7 case? Now I7 case will be fail. I7 cases fail. So what we do here is that we are control the operation of these two using enable. Using the enable. Okay. When E is 0, this one will be active. When E is 1, this one will be active. Clear?
So can you repeat it?
Yeah. Now what we do is that we just connect the enable pin. Okay, because in the decoder or encoder the enable is very important. So we just connect one enable pin. Okay, and with the help of this enable pin, I can connect this enable pin with particularly two circuits up and down in a way that means at a time one particularly encoder will be working. At a time only one encoder will be working.
Means when enable is zero, the upper
The
encoder
lower one will be working. When enable is one, the upper one will be working.
okay.
Okay. Now, if this is the pin number 1 and this is the pin number 1, so we are getting a adding of this one, the o-ring of this one, and we are getting a y. We are o-ring of this one, and o-ring of this one, we are getting a y. Okay. And with respect to this enable, we are getting a y. We are getting a y. Okay. Now explain. I explain this. Let's assume the E is 0. Okay. So There is no effect of this particularly pins input pin. There is no effect of this input pin. Why? Because my upper I4 to I7 pins decoder will be the disable. So either should I connect any of the input, there is none. Okay. Along with that, Y0 is 0. Y0 is 0. Now, if I connect a I3 as a 1, I3 as a 1. So output of this pin is 1, output of this pin is 1. Okay. And output of this one is either 0 or 1, don't care condition, 0 or 1. Okay. So this 0 and or 1, don't care with the this one and ORing of this one. So Y0 is what? 1. Okay. Don't care condition, ORing with 1 is Y1. So again Y1 is 1. Any doubt? I just repeat it again. First of all, I consider the enable pin is 0. Okay, enable pin is when enable is 0. So here we are getting 1, here we are getting a 0. So that means no effect of this one. Upper one decoder. Okay. Now, if I connect I3 as a 1, I3 as a 1. So with respect to the decoder definition, this I3 will be, due to this I3, both particularly point will be the 1. Any doubt? Now, if this is 1, and upper one are the don't care condition. Upper one are the don't care condition. Now, this 1 don't care with 1, sorry, 1 ORing with the don't care condition becomes the 1. Because if any of the input is 1, output is 1 in our case. Second output input will be the either 0 or 1, don't care, but there is no effect of that. Because one input is 1, output is 1. Clear? So what is the value of I1? Y1 is 1. Similarly, if I am talking about the Y0, so one input is 1, one input is don't care. One ORing with don't care is always 1. Why? Because the don't care is either 0 or 1, and in the case of OR gate, any of the input is 1, output is 1. Clear? And what about Y2? This is directly connected with the enable pin. So if enable is 0, Y2 is 0. So with respect to I3, this is the binary code of I3. It is correct. Now we take some other example is that if enable is 1. If enable is 1. Okay. Now if enable is 1, that means these four is basically the don't care condition. These four are the don't care condition. Okay. Now I connect one as a I5. One as a okay. Now when one as a I5, so Y0 is 1 and Y1 is 0. And here we are getting a don't care condition. Okay. Now if one don't ORing with the don't care condition, so Y0 is 1. If 0 ORing with the don't care condition, we can't say what is the output or in. What is the output of that? Okay. So we are assuming that this is the don't care condition. Okay, maybe this is the 0, maybe this is the 1, depends on the don't care condition. Clear? Now, if enable is 1, that means Y2 is 1. Y2 is Okay. Any doubt?
So here, Y0 is connected to LSB of the both decoder, and Y1 is connected to the MSB of the both decoder.
Hmm.
And why the enable is connected to Y2? It's important.
Why the enable is connected to Y2?
Yes.
Because when the enable is 0, okay, so the lower one will be working. Okay, and this for the lower one, we are getting the I0 to I3 as a combination. So either the input is applied for I0 to I3. So if we are talking about the I0 to I3, the binary number for I0 to I3 is 0002 to 011. So the MSB is always 0. Okay.
Yes, yes, yes.
And for the 4 to 7, this one. So what I do, 4 is 1002 to 111. So MSB is 1. So what should I do? I directly connected the higher MSB with the enable. Okay.
Yes.
Sir, this question is over, sir.
Yeah.
Can you take one example, sir?
Regarding related to,
Uh, Sir, can you take new page
yeah.
and consider 2:4 decoder?
Hmm. Okay.
Input side
Board decoder.
C and B. Yes, input side C and B. C is connected to I1 and B is connected to I0.
I1, I0, C,
So first thing, yeah. So first thing is that first doubt is, sir, if nothing is given, so 00 means I mean, sir, C and B is the input and I1, I0 is there. This means that I1 is higher bit or I0 is higher bit. Nowhere mentioned that which is LSB, which is MSB, sir.
What is the meaning of this I1 and I0? Can
So
you
it is
tell?
a decoder, sir, decoder.
Yeah, it is a decoder, but what is the meaning of I1 and I0?
Sir, input, sir,
Input.
two input
And
for
what is
out.
the meaning of 1 and 0?
Sir, what I understood, if it is I0, I1, then I will write 0001 1011, right? So it is I1 and I0. This means that I1 is LSB or I1 is MSB.
What
This
is
is my doubt.
what is the meaning of 1 and 0?
Sir, if it is
You are solving the Boolean expression now. So if I write a mean term M7, so what is the meaning of M7?
M7 means 0 1 1 1. Sorry, M7 means yes, 0 1 1 1.
0 How you define that? It is the MSB or MSB. Should I consider the 0000?
Can you repeat, sir?
Can I consider the M7 as a 0000?
No, sir.
What is the M5?
M5 means 0101.
0101. How should you know that one? Can I consider as if this is the LSB, so this is the LSB, LSB1 and LSB2. So it is a 0011 is possible. What is
Sir,
the meaning
as
of this 5 and 7? What is the meaning of this 5 and 7?
sir, because it is a mean term, no. So mean term
So
means
what is the meaning of 5 and 7? I am not asking about the M. M is mean term. What is the meaning of 5 and 7?
5 means
It shows the number.
yes.
Similarly, what is the meaning of 1 and 0? Yeah, here. If 1 and 0 not define that it is MSB or LSB, so I should put it as a I or I. Why should I put a I1 and I0?
Because it is a 2:4 decoder, so input will be
So
only 2 bit.
okay. So can I put as a input and input I and I? Why should I mention as a I1 I0?
Sir, this is only my doubt. That's why I asked you, sir.
I put
So
as a I and I input is not. So I can put as a I or I. Why should I mention as I1 and I0? What is the meaning of I1 and 0? 1 and 0. 1 is higher than 0.
Sir, if it is upper, no, if it is written upper, I mean,
Anything. That doesn't matter. If it is a I1,
okay,
1 is higher than the 0, so it is MSB.
okay, got it, sir. Sir, now take D2, D2, D3 output of
Yeah.
means output second and third output you take
D3,
connected to.
D2, D1, and D0. Okay.
No, sir. You take in normal order, sir. D0, D1, D2, D3.
Any order I take, nothing problem. If it is a I3, a D3, no worry about that one. So D3 is MSB.
Okay, D2 and D3 connected with XOR gate.
Okay. D2 and D3 connected with the XOR gate.
And it is connected to another 2 is
You
to
are
4
asking,
decoder.
you are asking the question, assignment question, I think so.
Similar kind of
Yeah.
the approach how to solve. Instead of XOR gate, you can take any gate.
Okay.
Just just approach I want to clarify.
Yeah.
Uh,
So let's say it connect with the AND gate.
yes, sir. And now you give
Now
it to
we are
another
getting
2 is
this I1 and I0. I connected as A. Okay.
yes, sir.
Now
I1
D3,
is connected to
D2, D1 and D0.
yes.
Okay.
And any of the output connected to any of the decoder output, you can take F.
Okay. So I just connected D1 and G0 with the NAND gate.
No, sir. Okay.
It is my choice, no?
Uh, if you
I
take
can take
single
any other
output, then
option.
it.
Why? It is
Oh,
my
okay. No
choice.
issue. Okay. No issue, sir. Now
Yeah.
I am, sir. Now I am telling the expression. You tell me whether I am correct or, I mean, what I
C,
understood
B,
is right or.
C, B. Initially, I am taking a C and B.
Yes,
Okay.
sir. So it is a C0. I mean C bar B.
0, 0, 0, 1, 1, 0, and 1, 1.
with DC and its input line. चले कोचा ने गलत पढ़ा कोचा ने ही गलत पढ़ा then equal to indicator is
Okay.
again with
See,
B C A line
uh, just what you are asking.
Sir, I am saying is first output will be 0, right? Output of first decoder will be 0, no? Sir, someone is speaking, so I am not able to. Hello, sir.
Hello.
Yes, sir.
Yes.
Sir, screen is not visible.
Okay. Yeah.
So here the output of AND gate will be 0, first decoder.
Okay. So now if we are seeing the C and B. Okay.
Sir, first thing, screen is, are you sharing the screen, sir?
Yeah, screen is shared. Screen is already shared. Please confirm everyone. Is screen is shared or not?
No, sir, your screen is not shared.
But it is
It is
shared.
visible, sir.
Visible now? Yeah.
it is visible sir
Yeah, exactly. Okay. So let's I take as a y1 here. Okay. When CB is 0, 0, my D0 is 1. When CB is 0, 1, my D1 is 1. When CB is 1, 0, my D2 is 1. And when CB is 1, 1, my D3 is 1. Okay.
Yes, sir. So D2 expression, if I want to write expression only for D2, then I need to write CB bar, right?
CB bar
Into CBs. No
and
plus what? And get.
multiply with CB.
So output is 0, sir. And get output will be 0.
Y1 is 0.
Yes.
Okay.
Uh,
Now
and then,
Y1 is connected. Now the for the second one in select line is the Y1 and A.
yes,
Okay. So
yes,
Y1 is always 0. Okay. Now
yeah,
A value is 0 or A value 1 is possible. Okay.
okay.
If A value is 0, so it's selected D0. So my D0 is 1. Okay. And when A value is 1, my D1 is 1. But in the case D2 is always 0. Why? Because in the input side, combination is not possible to select the D2 is 1. Okay.
So can you repeat? Can you repeat? Why D2 is always 0?
Why D2 is always 0? Because we have only two combinations possible. One is the 0, 0 and second is the 0, 1.
Yeah, okay. Actually, sir, yeah, that's right, sir. In this case, sir, Y1 output is either 0 or 1. Suppose somehow, if it is some value, let us say
How is it
any value.
possible? How is it possible? If you are taking the exam question related to the assignment, you go in that part, that is up to this. But if you solve this question, okay, the approach is this one.
No, sir, instead of AND gate, can you take OR gate?
Why?
So
You
that
can
it will
solve
leads to
you can
it.
solve it by your own, na? You can
Sir,
solve
I
it by
have
your
short.
yeah.
Sir, I
Okay,
have.
you solve
Sir,
by the whole gate.
sir, please
Okay.
listen, sir. Please
Yeah.
listen. If you take OR gate, then it will lead to variable, not a Boolean value 0 and 1. Okay. If
Okay.
you instead of AND gate, if you write OR gate, then it will be C only, no?
Yeah. Okay. See the
Because
only.
B and B bar will
Yeah.
be 1.
Yeah.
Now C and A is there. So then we need to follow the same steps like earlier
Yeah.
case.
Yeah.
Okay, okay,
The
okay. If it is
decoder is 2 4, then why can we take the other particularly different procedure for the first and second one? The same approach, na? We have to identify the I1 value. Either the I1 value is C, either the I1 value is B, either the I1 value is 1. We have to approach the same approach.
yeah, that's okay, sir. Actually, if it is many value, no, then it is confusing, sir. It's okay, sir. Thank you, sir. Thank you so much. You clarify my doubt, sir. Thank you
Yeah.
so much, sir.
Okay. So any scenario doesn't mean that any scenario what is the combination, like we are taking the two cases. If I take cascade 3 or 4 also, no issue with that one. Every decoder will be the working is same. Okay. It
Sir,
is
can
yeah,
I ask one more question?
yeah.
Sir, if suppose if input is 10,
Input is 10. That means
uh,
C and B
uh,
is 1 0.
no, not in this question, another question.
Okay. Okay.
Takes any mux, sir,
Okay.
random mux, and if number of input line is 10,
Number of input line is 10.
then how to find sir select line?
So the select line is always a, like for example we have a 2 raised to power n cross 1 is the basically that particularly combination. Okay. Now and the select line, like for example we have a n cross 1 is the mux. Okay. What is the size of the select line? Select line is log 2 base of n. So if 10 is the select line, 10 is the select line, we have a 1 as an output line. Now how many possible solution is there? So log 2 of 10. The value is around 3.2. Okay. Now next integer value is 4. The select line is 4.
Okay, got it, sir. Thank you, sir. Thank you so much, sir.
Okay, we always take the highest integer, upper integer of that.
N is the number of input, right?
Yeah, n is the number of input.
Okay, thank you, sir. Thank you so much.
Maybe possible we have only 12, only 13. So what should we do? Like in this case, what should we do? If we are taking the 4 select lines, so our multiplexer size is what? Automatically the size is 16 cross 4. 16 cross 1. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now 11, 12, 13, 14, 15, 16. 4 is the select line. Okay, 1 is the output. Now we are applying the input as a 10 pin. We are applying the input as a 10 pin in a 10 pin, and 6 pin is connected as a ground. So that is not used. Okay.
Okay, sir. Thank you, sir. Sir. Then who will keep this ground? Because our question is only number of input is 10. Then
Only the
if
number
we
of input is 10, na? But 10 cross 1 multiplexer is not available in the market. So the
Okay.
user who use that particularly mux will be grounded 6 lines.
Okay, sir. Thank you, sir.
Okay. Like for
Okay,
example,
sir.
in our fiber box, okay, optical fiber is there in our locality, and fiber box have a 64 connections. Okay, that means from that box, our line will be distributed by 64 users. Okay, but there are only 10 houses are there who need fiber optical, communication, or basically network. Okay, so we connect 10. What about the 54? We connect as a ground. Okay, we connect as a ground. When in the future, when some houses are also required, that one we connect that particular ground with the optical fiber and deep the connections. Okay.
Sir, in this type of question, there will be always ambiguity, sir.
No, I.
Because if someone is asking if 10 inputs, then also answer will be same. If someone is asking 11, then also answer will remain same.
Yeah.
11, 12, right?
Always the thing is that your multiplexer is available in the 2 raised to power n number of input lines. Okay, my like 2, 4, 8, 16, 32 lines are available. Okay, if your input is lesser than that one, okay, so you have to grounded the other lines. Okay, like for example, we have a 32 plus 1 mux is available. Okay, but only the 17 connections are there. The 17 will be applied to the multiplexer, and remaining line will be grounded. Any doubt?
So is it necessary to take 4 select lines as you told that there is 10
Because
inputs?
when we are taking the 3 select lines, so only the 8 input is possible, but the 10 user is there.
Okay, to cover the maximum input we have to
Yeah.
do.
Okay, so what we do, we are using the 16 cross 1 mux. Okay, in this we use the 4 select line. Now 10 lines will be used now at a time. Okay, maybe possible in the future some more particularly connection will be required. Like similarly, set top box, we are taking the particularly optical fiber box. Okay, so every time in your when you basically go with the optical fiber connection, so there is one box is available. The possible connection from that box is 16. Okay, if 16 houses are there, okay, so no problem. If less than 16 is there, no problem. Why? Because like for example nowadays 10 particularly connection is there. Okay, out is 10 output will be provided to the 10 houses. 6 is available. So if one new house required, you can provide the connection to this particular DP. Okay. 1, 2, 3, 4, 5, 6. So 6 connection you provide. But when the connection is 17, so what should you do? Either you basically say to one person that connection will not be here. Okay. So if one person, you can say that there is no particular connection is provided. But if it is a 2 person, 3 persons, 4 person, 4 extra persons will be required. So what will you do? You have to change your connections box from 16 to 32. Now from that one you can provide the connection. Okay.
Yes. And so I was having doubt in week 6 period.
Week 6, yeah. I just checked that.
Actually, there are 5 questions.
In the week 6.
Yeah, means I have 5 doubts in 5 questions.
Okay.
It was basically I wanted to know the method also to how to solve it.
Okay. Give me a second. Week 6.
So the question was 7, 8, 12, 13.
Question number 7. Okay.
7,
Yeah.
8, and 12,
7 and 12, 13. S and C you are taking that one.
13. Yeah.
Okay. Uh, so you have to implement this. So first option is that now first of all check that how many mean terms. What is the maximum size of mean term is available you required in that one. So if you go with the question, so you see that M7 is available. So that means you required a 7 minimum. M0 to M7 8 output is required. M0, M1, M2, M3, M4, M5, M6, M7. So for selecting the M0 to M7, 3 input is required: I2, I1, I0. Okay. Now your S will be implemented by the combination addition because it is SOP term. So 1, 2, 4, and 7. So 1, 2, 4, and 7 connected with the OR gate. So your S will be designed. Okay. Similarly for C, 3, 5, 6, 7. 3, 5, 6, 7. Take a O-ring on this one and okay. So 1, 3 cross 8 decoder and 2 OR gate is required.
Oh, actually I was confused. It was easy.
Yeah.
The same approach is for the 8 question also, no?
The total number of NAND gate required to implement a 4x1 mux. Okay, you have to design a 4x1 mux. So initially you have, if I write a mux equation, so it is a 4 inputs, 2 select line, 1 output. So what is the equation of mux is? Y is I naught S1 bar S0 bar plus I1 S1 bar S0 plus I2 S1 S0 bar plus I3 S1 S0. Okay. Now you have to implement these with the help of NAND gate. Okay. Can you implement this one with the help of NAND gate?
So
Yeah.
I didn't got it.
Yeah.
I didn't got it, sir, actually.
Your 4x1 mux is this one. This is the equation of your 4x1. Now
Yeah.
you have to implement with the NAND gate. So if I take a S node, so this is the S node bar. This one is the S1 bar. Okay, initially what I do, I just implement with the help of simple. Now we are using one AND gate, okay, where I am taking the I node also. Okay, similarly, I am taking the S1 bar and S node, sorry, not this one. Okay, now I am taking the and okay, I1, I second I2, so that is the S1. S1 I have to take it from here. S0 I am taking from here. Okay, and I2 I am taking. This is the AND gate, and fourth one is the I3 S1 S1. S1 is already here. S0 I am taking from here. Okay, I2, I3. Sorry. Now we are using the OR gate. So your equation Y is okay.
Yes, sir. Yes, sir.
Now I have to use this one, implement this one with the help of NAND gate. So this is a one NAND gate,
Yes, sir, I got it.
one NAND gate two. If I use one bubble here and one bubble here, so this one is a NAND gate. If I use one bubble here and one bubble here, NAND gate. If I use one bubble here and one bubble here, NAND gate. And if I use one bubble here and one bubble here, NAND gate. So two already NOT gate, 3, 4, 5, 6, and last 7. Okay.
Yes, sir. It is clear.
Now 7, 8. Now next
12 and 13.
12 and 14. So if you see in this particular diagram is that if your select line is S1, S0, Y. So if your select line is 0, 0. Okay. So Y0 is C. When your select line is 0, 1. Y0 is Y is I1. And what is I1 is B bar, B bar, X or with S1. S1 is 0. Okay. When I'm taking
Sir, in the previous question, in the last stage, you haven't used the NAND gate.
this one is the what is this one? Bubbled OR gate is what?
Oh, okay, okay. Is it okay to use bubbled OR gate as a NAND gate?
Yeah, exactly. You can see in the particular this one. Gate 2 is universal gate and NAND gate. Okay.
Okay, okay. Got it, sir.
Now when S1 and S0 is 1, 0, so it is a B bar XOR with 1. And when it is a 1, 1, it is a C bar. Okay. So for this one, can I write a equation is the A bar, B bar, C. Why? Because it is a A0 and B0. So A bar, B bar, C. For this one is the equation is the A bar, B. Well, now what is the property of XOR gate is that if any of the input is 0, output will be the other input. Or output basically this particular XOR will be behave as a buffer. Okay. So if any of the input is 0, it behave as a buffer. So it becomes A bar, B, B bar. Okay. Now 1, 0, so it becomes A, B bar, dot. If any of the input is 1 within the XOR gate, the output is the inverter of the other input. So B bar is applied as the input, so output is the B. Okay, and last one is the A, B, C bar.
So, sir, in second and third case, it will be 0 only.
Wait a minute, wait a minute. It is a 0, 1, 1, 0. So it is a bar B, and when we are taking the XOR gate, okay. So can I solve for the Y? So it becomes a B bar dot 1 plus B bar dot 0. So it becomes a B bar. And this one is as a B. It's B. Now if this is the scenario, so it becomes a 0 and 0. It is a bar, B bar C, and it is a B, C bar. 116. And when I should write as a in this form is that y is a XOR b bar. Oh, sorry. I2 is directly b bar. I2 is directly b bar. So it is a b bar XOR 0 is b bar, and the equation for this particularly is a bar b b bar. So it becomes a 0. And for when it is a 1 0, I2 is selected, and I2 selected is I2 is simply b bar. It is a b bar. So it is a b bar. Clear? It is a b bar.
Sir, in I1,
I1 is 0.
I1 is 0. No, sir.
Can I repeat it again?
Yes, in I1 only I'm confused.
Okay. So what is the I1? I1 is nothing but a XOR b bar. Okay.
Yes.
So what is the value of a? A is 0. So 0 XOR b bar. That is what it is, a b bar.
Yes, sir.
Okay. Now can I write a equation for this one? So it is a bar b b bar. A bar b b bar.
It is 0.
0. Okay, so that's why I1 is 0. Clear?
Okay, sir. So we have to take the max term, no? On this.
Yeah. So first of all, we define the mean term. So it becomes we have a bar, b bar, c as a mean term, a, b, c bar as a mean term, then a, b bar. Can I convert it to the standard SOP? So it is a multiply with c plus c bar. So it is a bar, b bar, c plus a, b, c bar plus a, b bar, c plus a, b bar, c bar. So which is the which mean terms are available? It is a 1, it is 6, 5, and 4. So these are the mean terms. Remaining is the max term. 0, 2, 3, and 7. That is a 5m, and it is a 6. Okay?
Yes.
So 12 is completed, now 13.
Sir, in the question 4 of the week 7 grade assignment, the options are not matching.
Option. Okay, wait a minute, I just check. Question number 13.
Yes.
So we have to implement as a F, A, B, C, and D. 5m, 2, 3, 4, 6, 8, 10, 14, 15. So can I convert into the sigma m 0, 1, 5, 7, 9, 11, 12, 13. Okay. Now we have to design as a 4 cross 1 mask. Okay, so two select lines are available. Two select lines are available. Now, if A and B are the select lines, so we are selecting the A and B as select. What is the select line position for 2 0 0 0 1 1 0 and 1? And C and D are the inputs. So just mention as 0 0 0 1 1 0 and 1. Remember again, we are not representing these number in the KMF form. Okay, because KMF will be used for the representation of number in the grayscale, but here we directly represent.
Yes, sir. We have cleared that out.
Okay,
Yeah.
so now 0, so it is defined term. Okay, I just mentioned as a 1. 1, it is a defined as so A, C, sorry, D is 1, C is 0, A is 0, and B is 0. So this is the defined term. Sequence is always F, A, B, C, D. So A 0, 0, 0, 1 is the one number, so it is different. Now 5. 5 is 0, 1, 0, 1. So this is the AB and this is the C. 0, 1, 0. 0, 1, 0, 1. So it is different. 7. 0, 1, 1, 1. It is different. 9. 1, 0, 0, 1. 1, 0, 0, 1. 11. 1, 0, 1, 1. 1, 0, 1, 1. 12. 1, 1, 0, 0. So 1, 1, 0, 0. It is a different. And 13. 1, 1, 0. So 1, 1, 0. Clear?
Yes, sir.
Now if you are talking about this one, so can I write as a C bar D bar plus C bar D? C bar I am taking, so it becomes a C bar. Okay?
Yes,
If I combine these two, so the equation is C bar D
D.
plus CD. So D is the term. If I define this one, again same as the previous, so D is the term. If I define this term, so again the previous first one, so it is C term. Okay? So now AB is 0, 0, that means the I0 is select. If AB is 0, 1, I1 is select. If AB is 1, 0, I2 is select. And if AB is 1, 1, I3 is select. Okay, so what is the I0 is C bar. Okay, I0 C bar. The first and third option. Then I1 is D. I1 is D and D bar. So 1, D. First option is correct.
Yes. Yes, I got. Thank you, sir.
Now we have question number 4. No, the option is correct. Option is available and option is correct for this one. Graded assignment 7, graded assignment 7, question number 4, options are available. Correct option है होगा. Okay?
But sir, it is not showing like me and my friend have tried it. We have the same answer, but it is not in the option.
The options is available. Options are available. That is the I note and I one. Either you check it again, the options are available. Okay?
Okay, sir. Okay.
Any other doubts? Any other doubts? No? So shall we close the class?
Sir, 1 minute. Can you show your options? Okay, it is the same. I have also same options.
Yeah, it is on the same portal, so same options are available.
Class over?
No, just tell me.
No, sir, screen is not visible. That's why.
Yeah, it's been like this. Stop sharing. Mhm. One thing you can do in that one, either you are getting confused in that one, so just take it, create a truth table of C, B, and A. Okay. In the question number 4, you can do that. You just create a truth table of C, B, and A. I think you will get your answer.
Okay, sir.
Have
Okay.
you shared the, sir, did you share the screen?
No.
Okay.
Okay, just create a truth table for completely
Yes, sir.
C,
Okay,
B,
sir.
and A. Then you get your answer.
Sir,
Yeah.
in quiz one, sir, I got less marks, sir. And how to check why my answer is wrong?
I think you have the answer keys available with you now.
How, sir?
Okay, answer key is not uploaded yet.
No, I don't know, sir. I mean, how to check, where to check?
On the portal, I think so.
Okay. Sir, can you tell me what is the quiz one maximum mark?
I have to check the sheet. Give me a second. Quiz one. $97.5. No, 100. 100 is the maximum marks.
I mean, sir, what is the highest score, sir?
100, 100, 100.
Okay, someone has scored 100 also.
Yeah.
Okay,
100,
sir.
97. 97.5 is also the score.
Sir, who, sir?
Sir, mine is only 85, sir. I wrote all the correct, but except one question, I did all questions correctly, sir.
So that,
Still, I got only 85, sir.
so please verify your answers. So I think
Sir,
you will
how
get.
to? I mean, where to check, sir?
I will upload the answer sheet. Basically, where answers key. Okay.
No, sir. Response answer sheet. I might be. I mean, response. Particular student can see their response
No.
on one-to-one basis. Let us say if 10 students are there, all 10 students can see their answers. I mean, their respond.
No. No.
Okay.
You can't see your responses. If you remember that what you mark in your examination on the basis of that one, we can provide you the answer. So please verify you can that which question is incorrect if you remember the answers.
Okay. Another thing, sir, can you allow from next quiz one is over? From next quiz, sir, we can carry rap questions, sir.
We can.
We can carry. Can we carry rap question paper? Rap question paper.
It is not at our hand. It is a policy that from the so you just drop a mail to the support team. Okay. So it will not decided by us. It will be decided by the
Oh,
support team. Support team will send a message to the in the examination center. This they will allow.
okay.
Okay. So yeah, one student guy who is getting the 100 marks. His roll number is last Your last 4 digit is 0026. 310026. This is the number. Okay.